can also have heteroatoms in the ring, so like oxygens and nitrogens instead of just carbon. So pyridine is benzene, but it's got a nitrogen in it, so it's not benzene. But it looks like it. And you can see that it's also got the 6 pi electrons right here. But pyridine has a lone pair as well. So you might wonder, does that mean it has 8 pi electrons? Then it's anti-aromatic? And the answer is no. It turns out that these can be conjugated, but then it doesn't have to include those. So these lone pairs actually are not part of the pi system. So they're not in a p orbital. To be in the pi system, you have to be in the p orbitals. So that means this nitrogen, which is sp2 hybridized, these lone pairs are in an sp2 orbital. And that's because the p orbital is occupied already by this pi bond right there, right? So then that p orbital here is already taken. And we've got p orbitals all around the ring, right here and right here. And there's actually delocalization, so that's actually spread out like that. And notice this lone pair is available. So that means it's a good base, because if the lone pair was delocalized into the ring, then it wouldn't really be available for grabbing a hydrogen. But since it's separated, it's sort of out there, it can grab a hydrogen. So that's what makes pyridine a good base, a stronger base than if the lone pair was conjugated in the system. Let's look at Parole now. Parole has a lone pair also, but do you see the difference? Where would you say this lone pair is located? Is it in an sp2 orbital or a p orbital? Well, if we look at this pi system, we see 4 pi electrons here and here, but then we see this is a critical position for conjugation, right? So I could push these over here, push these over there, push those over here. So because of that, if I involve those lone pairs, turns out that I can have a Huckel number. So let me show you. If I conjugate, okay, I have delocalization clearly. So that's great, because then that gives me 6 pi electrons, and now I have something aromatic. But I need the lone pair to make it aromatic. That means the lone pair is in the p orbital so that it can be delocalized in the pi system. So this lone pair on Parole is in an unhybridized p orbital because that nitrogen is sp2 hybridized. All right, so that's the difference, and you should be able to look at a molecule and be able to tell me what orbital it's in. Okay, so pyridine, again, it's in an sp2 orbital because the p orbital is already taken up by the pi bonds. So this is an sp2 orbital. That makes it a stronger base, and that's why we used it in the alcohol chapter as a base for PBr3, pyridine, or SOCl2 thionyl chloride in pyridine. It was a non-nucleophilic base. Parole, on the other hand, is less basic because its lone pair is involved in the delocalized pi system. So it's got to be in a p orbital if it wants to be delocalized. So the hybrid orbital diagram is, okay, remember this from Chem 261? This is why I made you learn that, okay? All right. So I've got pyridine here, and I'm going to have the lone pair out here. And remember, this is this molecule up here. Okay, so I sort of messed it up now, but all right, so here we go. Here's my p orbitals in a different color. So my pi system, and so that's where I have a pi bond here, a pi bond here, and a pi bond there. But they're delocalized, so I'm going to show them sort of like that. Okay, so this is in an sp2 orbital. And I didn't draw all my sp2 orbitals, but you know that this is an sp2, this is sp2, and this is sp2 to the carbons next door. Okay, and then this carbon over here is sp2, sp2, and a hydrogen, sp2. So these are all sp2s in the 6-membered ring. Now let's look at Parole. Parole is a 5-membered ring with nitrogen. And it looks like this, and it too has a pi system like that, and we had 2 pi bonds, one here and one here. And so we have to have a lone pair here in order for there to be delocalization that way, so that we can spread that out. So that means both of these are aromatic. It's just that the lone pair is in a different spot. And so this nitrogen has a hydrogen on it, and the hydrogen's occupying an sp2 orbital with the nitrogen. So the s orbital of the hydrogen is overlapping with the sp2 orbital of the nitrogen. So the nitrogen here is using 1, 2, 3 sp2 bonds for its sigma bonds. Its lone pair is involved in the pi system. Okay, so just to be more explicit, I'm going to label this one as in an sp2 orbital, whereas the nitrogen's lone pair in this one is in a p orbital. And then these are electrostatic potential maps. They sort of show you where the charge distribution is. So remember we said for pyridine here that this lone pair here was actually in an sp2. It's not in the delocalized pi system. So you can actually see it sort of hanging out right here. Okay? And then with Parole, we saw that the lone pair was delocalized in the system to gain aromaticity. So you can see that the red represents the electron distribution, so negative charge. So you can see that negative charge spread out. So that sort of shows you proof of how that these are all sort of calculated based on theory. So for practice then, let's take a look at each of these examples, and we'll determine if the lone pair or one or both are participating in the delocalization. So for A, what I would do is look at the ring, make sure it's a ring, and make sure it could be planar and that it's conjugated. And that, so here I'm seeing 2, 4, and so I know that's not a Huckel number, so I need 6 to be a Huckel number. So I want to use one of these lone pairs for the aromaticity, and then the other lone pair could be sp2. So this one will be P and that one will be sp2. And the reason why is because I have 2 pi bonds here, so 2, 4, and I just need one more pair to make 6. So these will delocalize, and then I'll have one lone pair left over, just hanging out in an sp2 orbital. All right, so for practice, go through each one, find out which lone pairs are involved in the delocalization or aromaticity. And then also for additional practice, tell me what orbitals the lone pairs are in. Is it a sp, sp2, sp3, or p orbital? All right, guys, so for part B, it's the same thing. We have 2, 4, and so I need one of these to participate in aromaticity. So this one will be in the p orbital, and then I'll have one left over for an sp2 orbital. For part C, I see that I have 2, 4, 6, so that's a Huckel number already, but they can't be conjugated or else I'll be anti-aromatic. So I don't want that lone pair involved. So I'm going to say let's keep that lone pair as an sp3, and we won't make this planar and part of a pi system. So this one will be non-aromatic overall. For this one, I think you see it's very similar to part B. So we do want one of these involved right here. So that will be 6 pi electrons delocalized. That means that I have this one left for an sp2 if this one's part of the pi system, and this one will also have to be an sp2 because there's no room for it to be involved in the pi system because of this pi bond is already taking up this nitrogen's p orbital. Right here, I'm looking at this oxygen's already using its p orbital, so this has to be a lone pair that's sort of stuck in an sp2 orbital here. And the aromaticity is going on without the lone pair. It's already right here. And then here as well, this is already aromatic right here. I don't want the lone pairs involved, otherwise I'll have non-Huckel number, and also it's not conjugated. I'm not going to be able to push these electrons here, otherwise, see, this is going to be sp hybridized. It's going to be too crazy. Okay, too much. It'll want to be 180 degrees, and it's in a ring, so it's going to be a lot of ring strain if I do that. So these are just going to be in sp2 orbitals. They're not part of the pi system because the pi system's already aromatic right there. Okay, so hopefully that helps you. So any of the lone pairs that are in the p orbitals are participating in the aromaticity. So that would be this one and that one. Okay, and then sometimes you hear in the news about polyaromatic hydrocarbons. And so naphthalene is what's in mothballs. I don't know if anybody even uses mothballs anymore, but that's such a smell that reminds me of my grandma. Okay, but naphthalene 2, 4, 6, 8, 10. That's a Huckel number, so this is considered aromatic. 2, 4, 6, 8, 10, 12, 14. That's also a Huckel number, so it's aromatic. 2, 4, 6, 8, 10, 12, 14. That's also aromatic. So all of these fit the aromatic requirements.